Yo, what up? It's your boy back again with another video. If you clicked on this video to learn about black holes, you're absolutely in the wrong place because I'm very dumb. But you're here for a reason, so let's get into it. Here are a couple things you need to know about black holes. Thank you for watching. No. Cut the music. We're not done here, okay? We're not done. Seriously, today we're talking about black holes, one of the greatest mysteries of our universe. For every black hole, there are two basic parts, the singularity and the event horizon. First, let's focus on the event horizon. The event horizon is basically a black hole's point of no return. At this point, the escape velocity becomes equal to the speed of light, meaning you'd have to travel faster than the speed of light to escape the black hole's gravitational pull. This means that whatever crosses the event horizon cannot escape from a black hole's gravity, even light. And you wonder why you can't see them. Another thing to note, these things are massive. They're absolute units. The biggest black hole known to man has a mass of 40 billion suns. That's pretty big. So let's say you're floating around space one day, just a casual Monday afternoon, and you accidentally cross a black hole's event horizon. What happens now? Well, the short answer would be that you're dead. You can't escape it. Once you cross the event horizon, you'd have to travel faster than the speed of light to get out, which obviously is impossible. I mean, hypothetically it could be, but let's stick to one hypothetical today, okay? So let's say you're past the event horizon, now things get interesting. Weird things happen to your body, like spaghettification. Yes, that is a real science term. Spaghettification is pretty simple. Imagine your body being stretched into a thin string, like a piece of spaghetti. Except in this case, your body continues to be stretched until it's just an extremely long string of atoms. That's obviously where you'd meet your death, but what would it feel like? You'd definitely feel some pain, but it would be quick, if that's any consolation. Prior to being ripped apart, you'd feel a stronger gravitational pull on your feet than your head. That's how strong the black hole's gravity is. You'd also feel like you have a really tight corset on because the black hole's gravity would squeeze you. Yeah, that doesn't sound very fun. So once you're all spaghettified, where do you go from there? At some point, it's theorized that your long string of atoms will reach the black hole's singularity. This is where things get weird and we honestly have no clue what happens. Also, I'm stupid and don't understand physics, but here we go. At the singularity, the laws of physics basically just stop working. The singularity is said to be a one-dimensional point with an infinite density and gravity, and where space-time curves infinitely. So that's where your atoms would go, to a place where physics just stop working. And you'd be dead. Sounds pretty nice if you ask me. Before I end, I want to touch on a couple theories out there about black holes that I find really interesting. For one, physicists like Stephen Hawking have theorized that black holes are actually doorways to other universes. So who knows, maybe your atoms would enter another universe. That would be pretty cool. Now let's talk about time travel. This has been explored in movies like Interstellar, which actually did a decent job of explaining it. But let me break it down, because apparently somehow I'm going to do a better job than that movie. There's something that exists called gravitational time dilation. Gravitational time dilation just means that the stronger something's gravity is, the slower time passes around it, because gravity is literally bending time. All of that is important because it could very well be possible to time travel while circling around a black hole. Let's say that this black hole you're circling has strong enough gravity that you experience time twice as slowly. For every year you spend orbiting the black hole, 2 years would pass on Earth. Basically, time is really weird and way more complicated than you think, and it's really just based on our experience on Earth. There's an article by the Science Explorer that explains this much better than I did. I'll link it down below. Okay, that's all I've got for this hypothetical. I'm gonna go jump into a black hole now because that sounds way better than what's going on here on Earth. If you enjoyed, feel free to like and subscribe. New videos are coming weekly now that I'm back from vacation. Follow me on Twitter if you want, that's linked down below. Additionally, all of my research links are in the description. One more thing, feel free to recommend some of your own hypotheticals in the comments down below. See you next week, and thanks for watching.